Hi, welcome to this video presentation. My name is Janos Haber and I'll present our paper Word Sense Distance in Human Similarity Judgments and Contextualized Word Embeddings. In a nutshell, we collected empirical data to investigate models of polysemic sense. We find that participants assign different levels of similarity to different interpretations, and therefore we find some evidence for a grouping of senses, which means that a fully underspecified representation of polysemic sense is probably incomplete. We also take a computational approach and investigate how well contextualized embeddings can predict the similarity ratings of different interpretations of a polyseme. We find in our experiments that these predictions are not very consistent, but we think that there is other information to be accessed in these contextualized embeddings and find some interesting approaches for future work. Don't worry if you don't understand all of these nutshell points, because I'm gonna explain in more detail what those points mean and what their implications are to the field. So let's start with polysemy. What is polysemy? Polysemy is the phenomenon where a word in different contexts can refer to different but semantically related concepts. And the easiest way to understand this is to compare it with what it's not, which is homonymy. In homonymy, words refer to completely unrelated concepts and they just by chance have the same name, basically the same word. So the match burned my fingers and the match ended without a winner. These two words match, they refer to very different things that they have no connection whatsoever. So it's just coincidental that they were spelled the same way. That's why it's called homonymy, so they just have the same name. In polysemy, the different uses in different contexts refer to semantically related concepts or to aspects of one specific concept. So the school is on fire refers to the school building, but the school band light up trainers refer to the rules and regulations, or maybe to the directorate. The school visited a new opera is a group of pupils, and the school won the football match is probably the football team. So that's why it's called polysemy, so there is multiple senses that can be invoked by this word in different contexts. Why this distinction is interesting is because we process homonyms and polysemes differently when we encounter them in a text or when we hear them. So far the observation has been that with homonyms we instantly make a decision of how to interpret them. So we instantly choose one of the different alternatives and take that as our interpretation, and if it's not the one that is favored by the context, we have to spend some cognitive effort to change our interpretation. That led to the hypothesis that homonyms are represented in individual entries in the mental lexicon. And if one of them is activated, the other ones stay inactivated. Polysemes, on the other hand, are shown to kind of not trigger this instant decision on what the interpretation is, but that the different sense interpretations remain active for some time, and a changing interpretation doesn't cost a lot of cognitive effort. So the idea here is that polysemy or polysemes, when they're triggered, stay underspecified, and you can still concretize them later in whatever direction you need. And the idea is that this is possible because the representation of polysemes in the mental lexicon is also underspecified. And if one of them is encountered, then all of the different senses in this underspecified representation are activated and are available for interpretation. In this research, we want to look into what is in this blank space between these two extremes in a spectrum of ambiguity, which are words that are semantically related but still don't really invoke a very similar representation. And the best way to test this so far has been co-predication. In co-predication, two different interpretations are combined in one single context. So on the left side, for the homonym, we could make a sentence like, the match burned my fingers but end without a winner, referring to these two different interpretations of the word match, and then the sentence is basically nonsensical. For the polysemes, it's often possible to combine different interpretations. So lunch was delicious but took forever is an okay sentence, even though we refer to lunch as an event and lunch as a food. Interestingly though, there are some polysemes that if you combine them in co-predication behave more like homonyms, and that's the case for newspaper. So the newspaper fired its editor-in-chief and got wet from the rain. While referring to two different aspects of the polyseme newspaper, to the organization and the physical newspaper, you cannot combine them into a felicitous sentence. So we want to look especially into those words that seem to have these different, more or basically less related senses, and see whether this fits with a fully unspecified representation of polysemy. Specifically, we built on the idea that the sense representation in your mental lexicon might be more hierarchical than so far assumed, and this hierarchy is based on the distance, or otherwise the similarity between senses. So here we look at the example newspaper again, and we assume three different sense interpretations, which are newspaper, the organization that publishes the newspaper, newspaper, the object, which is the physical newspaper that you buy in a store, and then newspaper as a source of information, so what you read in the newspaper. And the idea here is that, for example, the information interpretation and the object interpretation are more closely related than any of them are related to the organization interpretation. And that's why you can use the information sense and the object sense together. They're more closely related, while co-predicating them with the organization sense will often lead to kind of infelicitous sentence. So we want to see, is there any empirical evidence for these similarity differences in polyseme interpretations, and therefore some indication that this unspecified representation of polysemy is probably incomplete. What we do for this is we run a crowdsourced experiment where we present participants with sentences that invoke either the same or a different interpretation of a polyseme, and then see how they rate the similarity of these two different uses of the word. What we want to do with this experiment is to get a clear indication of sense grouping if it exists. And we use systematic polysemes, which are polysemes for which there's traditionally an assumption of how many different senses they have, and it means that the senses are clearly defined and distinct, and it's the easiest way to show that there's difference between interpretations. There's also polysemes where the differences are more nuanced, so they're a bit less suitable for this kind of experiment. We want to get an insight into the prevalence of grouping, so we test 10 different types of systematic policy and see if some of the types maybe lead to more grouping than others, or to a clearer grouping than others. We need a measure that's very sensitive to similarity and to nuanced differences in similarity. So we use a continuous 100-point scale for our ratings to get very fine-grained judgments. And lastly, because we also want to test contextualized embeddings, we use custom samples to make sure that there's no compounding effects of longer context or confusing context for these computational models. So starting with this last point first, what are the conditions we had for creating our samples? We wanted to make sure that the target words, so our polysemes or homonyms, always have the same function in the word, so they should always be the subject. They should always be at the beginning of the sentence, so either the first or the second word if they need an article. We want sentences to be as clearly as possible in invoking a certain sense interpretation of a polyseme, and we want them to be as short as possible so there's no confusing context that might overload the contextualized embeddings in the contextualized language models. Using these restrictions, we came up with a setup to create samples for our target words, in this case newspaper. And as we said before, newspaper is assumed to have 3 senses. So what we did is we created 6 sample sentences, 2 of each referring to each of the senses, so that we can combine either the same sense interpretation or cross-sense interpretations in our experiments. We have some polysemes that only have 2 interpretations, so there's 4 target sentences, and we have some with 4 which have 16, but altogether for the 10 polysemes that we tested, we get 67 sample pairs, and we augment that set with 30 control items containing homonyms and synonyms to see whether our participants actually rate similarity correctly or at least intuitively. And we have 53 filler items which have completely unrelated target words to check whether the ratings that we get make sense, and also to define basically the extremes in the scale and normalize it in a way. This is how our experiment looks like to participants. So we use Amazon Mechanical Turk to recruit participants, and then they would see this very short introduction text that tells them to rate the similarity of the highlighted words, and then they will see 10 pairs of sentences that invoke either the same or a different sense of a polyseme, or that contain homonyms or synonyms or filler items, and then they should rate the highlighted word similarity with this continuous slider. For the computational models, so the contextualized embeddings, we use Elmo and BERT. For Elmo, we use the pre-trained model available in the TensorFlow Hub implementation, and we use the second layer hidden state. So we calculate this representation for our target words, and then we use the cosine similarity to determine the similarity between two target words in different contexts. For BERT, we use the pre-trained model available in the Hugging Face implementation. This BERT model has 12 layers, a hidden state size of 768, and 12 attention heads. And here, because BERT, at least this version of BERT, works with sub-word tokens, we have to average over the output of different subword tokens if our target word contains multiple subword tokens, and otherwise it's just the output. So what are our results? We focus first on the results of our experiments with the human participants. First and foremost, we see that polysemes are rated significantly less similar than synonyms. That's an interesting first insight, because it shows that polysemes behave differently than synonyms. So there is something that makes some interpretation of polysemes to be rated less similar than others. And on the other hand, homonyms and fillers are far less similar in our experiments, so setup seems to make sense, and it looks like we get some interesting results for our polysemes. Looking at the polysemes in more detail, and specifically comparing sample sentences that invoke the same sense and pairs that invoke different sense interpretations of a polyseme, we find that the cross-sense interpretations overall are much lower than the same sense interpretations, and most of the same sense interpretations are rated to be virtually the same or highly similar, except for glass, which is an interesting finding because it shows that even with our careful setup of samples, we cannot always guarantee that sentences are interpreted in the way that we assume they are, and that they invoke the sense that we assume that they invoke. But this is already interesting, and it shows that apparently kind of the cross sense or these other senses might have some distance to the same sense pairs. What is interesting is you look at specifically one of these target words and see how the different sample sentences and their ratings relate to each other. And here we go back to newspaper again. And what you see here are the 9 different possible combinations of sample sentences to invoke either the same sense or a different sense combination. So if you remember, we assumed the newspaper had 3 senses: the organization, the physical, and the information. The red bars show the same sense combinations of organization, organization, physical, physical, and information, information. These are rated as virtually identical. And then we have in these 3 groups the 3 different cross-sense interpretations of first organization and physical, that's yellow, then organization and information in green, and physical and information in blue. And you see that there's different steps of similarity ratings here, and that, for example, the organization physical combination is significantly less similar rated as any of the same sense pairs, or for example the physical and information samples. So we see that apparently this physical interpretation of the polyseme newspaper seems to be further away than other interpretations of the word in this kind of constellation. And you might also notice the steps within the different color groups, and we first thought that they might be order effects, but we validated this and we got the same results even if we flip the order of the sentences. So how we explain these differences within a group is actually the very nuanced differences that individual context sentences invoke. So because we have to use different sentences to create the same sense pairs. We also use different sentences to create the cross sense pairs, and apparently these different contexts, even within a certain sense, invoke so different interpretations that we get sometimes significantly different ratings even within the same group. But overall, this shows that apparently, for newspaper at least, the physical interpretation seems to be further away from the organization than the information reading, and that information is somewhere in between maybe, but definitely that there's different distances between the different interpretations, and that they don't have all of kind of the same distances or a similar interpretation. There really are significant differences in the interpretation, and the distances between these different interpretations also differ. So there's a lot of evidence here that you cannot assume a completely unspecified representation of polysemes, because we see these nuanced but actually explicit differences in how they're interpreted. If we look at the contextualized embeddings, we see that they perform not as well as we thought for this experiment. So we tried to use them to predict the similarity patterns that we observed so far. And here you see a heat map of the similarity scores, and in a row there are all of the scores for a certain measure. So in the top row we see the human judgments, and the brighter a field is, the more similar this sentence pair was rated, and the darker is rated less similar. So we would expect that the contextualized models create a similar pattern of similarity, but as you can see, they do not. They sometimes get the similarity roughly right, but sometimes they get it very wrong, and overall they're very inconsistent in predicting the human similarity judgments. That's reflected as well if you calculate the correlations, and we see that actually the BERT word embeddings don't have any significant correlations with the human judgments. The other versions, so sentence embeddings or the star token embedding or even word2vec, sometimes have a significant correlation with some of the target words, but it's not very consistent, and also the correlation isn't that good in some cases, or most cases. So we see here that they're just very inconsistent in trying to predict these similarity scores. To conclude, what we found in our human experiments is that our participants clearly have a distinct interpretation of different polysemic uses, and especially if you use the same sense or a different sense, that gets picked up by the participants, which means that if you look into it in more detail for the specific target words, that we find empirical support of a grouping of senses, and that so that some senses are more similar to others, and that this similarity might be a reason for why some senses can be co-predicated while others can't. And also we find a gradedness in similarity rating, so it's not a all or nothing rating, which is interesting, because if we look at what this means for the field, is that we have some empirical evidence that a completely unspecified representation probably is incomplete, so we should think a bit more about maybe a hierarchical model of polysemic sense representation in the mental lexicon. But also we need to validate our experiments, so far we've only run one target word for every type of polysemy that we assumed. So we definitely want to run multiple target words for every class so we can see if there are any consistent patterns, and anything more categorical we can say about how the grouping works for different types of polysemes at least. And then, as I mentioned, that there's this graded notion of similarity. Maybe we have to rethink how we do word sense disambiguation, because maybe ambiguity and polysemy aren't those two extremes, but rather kind of a continuous phenomenon, and cases fall somewhere in between and might be more like homonyms or more like polysemes, or somewhere in between. Concerning the contextualized models, we find that in our experiments the models fail to reliably predict the patterns of word sense similarity that we find in our human judgments, but we think that there might be better ways to access word sense information than just using the output vector, so we might look into different layers or into fine-tuning, or using nonlinear functions to access subsurface information that is contained in these embeddings. And ultimately we just want to determine how much and what kind of lexical semantic information is in these contextualized embeddings, and is there enough to use them as a proxy to at some point replace costly human judgments and work with these cheaper computational measures. That's it from me. Thank you very much for your attention and for your interest, and if you have any questions, feel free to contact us. Otherwise, goodbye.